Good morning, Physics 20. I hope you guys are all doing well today. Welcome to the first of the physics YouTube videos that I am creating. And so just an FYI, these YouTube videos have been filmed out of order. I started filming them kind of partway through the year in 2020, March 2020, which we all know what happened then, yay COVID. So for online lessons, and now I'm going back and refilming the rest of the course. So we're a bit out of order here. So at one point we'll be at school, and then partway through the course you'll jump and we'll be in my home office. So just be aware that in some of the later videos from like dynamics onwards, you are going to be seeing a lot of things like due dates or constant reminder that there are no exams. By the time you guys are watching these videos, that might not be the case. So just be aware of that. Alrighty, y'all. Okie dokie. So the first set of notes we're going to be doing is we are going to be looking at the review. So this is a review of Science 10 and previous math courses that you would have done, and including your Math 10C and just previous years of math. And we're going to be bringing in some of the things that are really important skills that you need in order to do well in physics. All right? Cool beans. All right, so enjoy. Calvin and Hobbes, can't go wrong. So the first skill we're going to be looking at is really, really, really vital for Physics 20, or any physics, because it involves rearranging equations, okay? So when we're going to be rearranging an equation, they're going to be used in order to solve for different scenarios, right? And you're going to be asked to rearrange it, to organize it using your algebra in order to find a specific variable. Okay, so you have to isolate the variable you're trying to find by doing mathematical functions to both sides of the equation using your for operations. Okay, so very, very important thing that you're going to be doing is going to be your life in physics. Okay, so our example here, we're just going to pick one of these. We pulled that one out of math. Okay, and so identify the unknown that you're trying to find. Well, in this case, we are going to isolate for x. Okay, so we're going to try and find x. So when you're going to go into rearrange your equation, you are then going to isolate the chunk of the unknown by doing the opposite math function on both sides. Now, I want you guys in with your notes, which you guys should either A, have these notes that I gave you in class, or B, you guys should have these notes posted on Google Classroom. So one of the two, have them, write this down. Okay, so reverse BEDMAS is super, super important. That's going to be your key to rearranging the equation. So the order in which you're going to do things. So when we have 3x squared plus 9 equals 12, well, my reverse BEDMAS is going to be my addition and subtraction. So I am going to then start by getting rid of this 9. Because when you have a number bumped up against that x, that's going to be multiplying. Multiplying is here. This squared is the exponent, okay? So I need to isolate the chunk, get this guy where that x is alone, reverse BEDMAS, subtract the 9 from both sides. Okay, so plus 9 minus 9, that cancels. What you do to one side, you do to the other. Okay, so then I am going to be left excuse me, with 3x squared is going to equal 3. All right? Okay. So once our second step, ladies and gentlemen, is we are going to then multiply, divide, square root, etc. using our continued reverse BEDMAS. So once again, opposite math functions on both sides to isolate the unknown. So when we have 3x squared, reverse BEDMAS, well, we have an exponent and we have multiplication here. Okay, so because of multiplication, I reverse BEDMAS, so I'm going to divide both sides by 3. Okay, x squared is then going to equal 1. Once we have that, I then can square root both sides. Okay, to get rid of that square, that cancels, and the square root of 1 is 1. So therefore, x equals 1. Okay, I really hope this is all a review for you guys. Because all of physics is rearranging equations and solving for the unknown and applying theory to the equations, if you are all having a hard time with this, make sure you come and see me and we will do some more work with it, okay? But it's really important. If you don't understand this, you make sure you come see me, okay? Cool beans. All right. So this is a very important note here, ladies and gentlemen. If the unknown is on the bottom, okay, so as a denominator, a very easy first step for you to do is multiply by the unknown on both sides first to move it to the top. Now, this is a tip. You cannot magically move a denominator up to the numerator. It can't happen. So I'm going to show you guys with this particular equation here, and this is an equation we're going to be using in our third unit in Physics 20. Third or fourth unit. It depends on the order I decide to teach energy and circular motion. But that's circular motion. So that's going to be an equation we're going to use. And I will be asking you to solve for t in this equation. So you can't magically move something to the top. I'm going to show you a few different ways to rearrange this, and then I'm going to show you what not to do. So because it's the most common mistake I see with rearranging equations. So I want to solve for t. So what I am going to do, so AC is equal to 4 pi squared r over t squared. T is my unknown. So when I rearrange my equation, well, t is on the bottom. I need t to get to the top for me to isolate it for it. So I'm going to multiply both sides by t squared. By doing that, ladies and gentlemen, I then have t squared a is equal to 4 pi, oops, I dropped my r, 4 pi squared r. Now I can then rearrange, okay, to isolate t. T is now on the top. So divide both sides by a cancels, and then I am left with t squared is equal to 4 pi squared r divided by a. Well, I need to deal with the square, so I'm going to then do the opposite of squaring, which is square root, and I'm going to be left with t, and that cancels, is equal to the square root of 4 pi squared r over a. Sounds good, guys? Okay. Now, putting this into your calculator is ridiculously important. Now, notice how we have stuff here. We've got things that are on the top and things that are on the bottom. We assume that everything on the top is in brackets and everything on the bottom is in brackets. And you have to solve everything under the root first. So when solving for this, you would go 4 times pi squared times the value of r. Enter. Divide by a, enter, second square root, second answer. Okay, so it's very, very important. You need to treat the top and the bottom as if they have brackets around them, okay? Okay, alrighty-o. So that is one common way to rearrange this equation. So I am going to show you another. Once I erase this. Come on, erase, 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 erase. There we go. Yep. Okay, so AC is equal to 4 pi squared r over t squared. Now, this is essentially a shortcut. You know how the method I showed you previously involved multiplying by t squared and then dividing by AC? I'm going to do both at once. Okay, so what I am going to do is swap these guys. I'm going to trade their places. And the reason why this works is because of the method that I showed you in the previous step there. Oops, 2 4s. You don't want that. So 4 pi squared over t squared. A. Goodness. It's not even Monday. I can't blame it on Monday. Okay? And then once you have traded there, then you can square root, cancel, and then you can get your t, oops, that's already squared, and your 4 pi squared over a. So that is an acceptable method. You can definitely do that. That fits. And another method that you can do, which is generally not a very popular method because it involves inverses and not everybody likes inverses very much. So AC is equal to 4 pi squared r over t squared. A very common question I get is, oh, well, I'm going to divide out by 4 pi squared r to get them away from t. Can I do that? Yes, you can. But remember, t squared cannot miraculously move its way up to the top. You have to do math to bring t to the top. So I'm going to divide by 4 pi squared r on both sides. So 4 pi squared r on this side, and I'm going to divide by 4 pi squared r on this side. They cancel. Now, ladies and gentlemen, t's on the bottom. So if I have AC over 4 pi squared r, now this, ladies and gentlemen, is not equal to t squared. This is equal to 1 over t squared. T squared is still on the bottom. You can't miraculously bring them to the top without doing math. So now what I'm going to do is I'm going to take the inverse of both sides. The inverse is another term for a reciprocal, which means you take your fraction and flip it. So what was on the bottom becomes the top, and what's on the top becomes the bottom. You do that to both sides because that's appropriate math. Then, and it also can be communicated as an exponent to the power of -1. It means it flips it. Okay, so then I wind up with 4 pi squared r over AC is going to equal t squared over 1. Now, t squared over 1 is the same as t squared. And then you can square root. Okay, so that method is acceptable. That method is acceptable. The method I showed you previously is acceptable. Okay, but what I don't want to see and what will make me cry inside is if I see this. Okay, so if I see the same step here, but instead, after you divide by 4 pi squared r, I see if you leave it as AC 4 pi squared r equals t squared. That's wrong. That makes Mrs. Bray sad inside. Don't do that, okay? So this here, what the mistake, that is what it needs to be, okay? The t cannot miraculously come up to the top. You need to do math to bring the t up. Okay, so I know I'm spending a lot of time of this video on just one question, but trust me, it's a very important topic, and in class, when I do this exact same lesson, we're going to spend as much time with it, and I'm going to be even more weird and like wave my arms around and yell and be goofy, and that's how we roll. Okay, doke. So, ladies and gentlemen, if you have questions, let me know. So, what I want you guys to do is I want you guys to pause this video right now. Pause it. Well, I guess after I'm done giving directions. And then you're going to do these practice problems. So do these practice problems. These are in your notes. Take the time, go through them, do all 10 of these. Every single one of these equations, ladies and gentlemen, you're going to be using in Physics 20. They're all Physics 20 equations. So they're all on your data sheet, which I have put behind me. I know, my big old data sheet. I love it. So pause the video, do these practice problems, and then in the video, I am going to go over them. But I am going to go over them assuming you've done them and that you are simply checking your work. Okay, so that is why I'm going to go through them a little bit quicker. Pause the video, do these 10 questions, then watch the video to check your answers. Okay, dokey? Go Banes. All right, welcome. Welcome back, ladies and gentlemen. I am assuming you have actually paused the video and have listened to me and done these questions. So we are now going to rearrange each of these equations, okay, for the variable. And you guys are going to check your work. All right? All right. So we have, ladies and gentlemen, v equals d over t and arrange for t. So what you are going to do is you are going to, well, look at this. I can swap places. Okay, so which means t is going to equal d over v. Sounds good? Awesome. All right, so that is question number 1. Question number 2 is this guy. We're going to be solving for VF. Okay, now this is a very kind of a tricky one, and there's a lot of issues with this one, so pay close attention. Now remember, we need to treat the top and the bottom as if they have brackets around them. Remember, we are doing reverse BEDMAS. So what you're going to do is I am going to multiply both sides by t, okay? Because these are in brackets, they have to be last. So for 2, after I multiply both sides with t, I wind up with AT equals VF minus VI. Well, all I have left are my brackets. There's nothing left, so I'm now allowed to go into those brackets and do the work. So once they are, okay, once you've solved everything else but the brackets, you're allowed to break those brackets. And then we are now going to solve for VF. Well, here's VF. Well, it's being minused by VI, so in order to cancel that, I need to add VI to both sides. So my final answer is going to be VF is equal to A times T plus VI. Sounds good? All right. That's number 2. Number 3, we're solving for A. Now, this is a tricky one, and trust me, guys, we're going to be doing this exact same thing in class and equation later on in our first unit. And actually, this equation comes up in a lot of units, so you can see this equation a lot. This guy's going to be your friend. So for this one, remember, reverse BEDMAS, and we have to isolate that chunk. We have addition here. Reverse BEDMAS, addition and subtraction, we got to deal with first. So I need to subtract VIT. Okay? I subtract VIT because this is a chunk. And if I'm going to be getting rid of VI and T, well, they're attached together by multiplication because the letters are crammed together. Because of that, then you have to keep them together. All right, so once you subtract VIT from both sides, D minus VIT is going to equal 1/2 AT squared. Okay, now this is a second chunk held together by by multiplication, excuse me. Now that this chunk is held together by multiplication, now I can go and divide out everything away from A. Now, the thing about the 1/2, ladies and gentlemen, dividing by a half or multiplying by 2 are both correct ways to cancel this. Okay, I like to multiply by 2 because dividing by a half looks weird on a page to me, but truly, I don't care which one you do. Divide by half, multiply by 2, whatever. Same thing. So I'm going to multiply by 2 and divide by t squared. Okay, so multiply by 2. And divide by t squared. Okay, so when I rewrite this, I am going to wind up with my, A is going to be equal to 2 bracket D minus VIT bracket divide by t squared. Okay, all right, so ladies and gentlemen, notice my 2 is on the outside of my brackets here, all right? Because when you're going to multiply something over, you're multiplying it by that entire term, and at that point, it's the top there, okay? All right. Now notice we've got t and t squared. Can I cancel those? No, you cannot cancel these because this t is not in every single term, so you have to leave it as is, all right? Okay. If you really wanted, you could FOIL out the 2 here, 2 times D, and then 2 times negative VIT, but that's more work than you need to do, and your answer is going to be the same anyway, so I would just leave it. All right. There we go. So we're going to look at number 4, and we're going to be solving for L. So with your equation, our t is equal to 2 pi times root L over g. Now for this one, there is no addition and subtraction. We're trying to solve for L, so I'm going to divide out that 2 pi. So I'm going to divide both sides by 2 pi. That's going to cancel, divide by 2 pi. And then I'm going to wind up with root L over g is going to equal t over 2 pi. Now here, ladies and gentlemen, I need to keep in mind that my L over g, even though I didn't write it down here, those are in brackets. I have to get rid of the square root first. In order to do that, I'm going to square both sides. Okay, so that's going to cancel. And once again, you have to square everything. So you're going to put your brackets there. So L over g is going to equal, and if you want to make it easier, you can square everything inside it, write it nicer. So t squared, 2 squared is 4, and pi squared is pi squared. And then I can multiply both sides by g and get rid of that g. Okay, so when I write this out, I would have t squared times g divided by 4 pi squared is going to equal L. Sounds good? Awesome. Okay, so now we're going to go on to question 5. Now, number 5, I certainly hope you guys remember how to do, because that one was from Science 10, so that one from last year. And for this one, I am going to get rid of the 1/2 and the m. I'm going to multiply by 2, and I'm going to divide by m. So I multiply both sides by m times 2, both sides, m times 2, goodness. I multiply both sides by 2 over m. So multiply both sides by 2 over m. And I'm going to wind up with 2 ek divided by m is going to equal v squared. Square root both sides, that cancels. So I am left with v squared is going to equal 2 times ek divided by m square root. Get rid of that. All right? Okay. Now, for number 6, we're going to solve for v. Okay? So if fc is going to equal the mv squared over r, well, I am going to multiply both sides by r over v. Okay? So no, not r over v.
Hello, fine people. The lovely and talented Cam can now use a few teachers to join in the main conference room for some envelope stuffing. We've got the grade 12 ones ready, so if you are available, please come down to the office, and Pam will get us all set up. Thank you.
Okay, guys, I am now needed to go and help stuff report cards, because yes, it is end of June when I'm filming this. So I will go stuff report cards, and then I'll be back when I come. Actually, I'll finish this question. We'll finish this question, because when I come back, it's going to delete all these notes, and then we'll have more space. So I'll finish this here. So I'm going to multiply by r over m on both sides. So when that will cancel, and I will be left with v squared is going to equal fc times r divided by m. I will then square root both sides, and v is now going to equal fcr over m square root. Cool beans? Cool beans. All right, ladies and gentlemen, so I'm going to go stuff some report cards into envelopes, and then I will be back to finish the video. Sounds like a plan? If I can actually turn this off, that would be pretty cool. All right, now I can't get the thing to stop. Okay, guys, I will see you all later to finish the video. Ladies and gentlemen, I'm back from stuffing report cards into envelopes. We're going to keep going with our physics. So we left off with question 6, cool beans. We're going to go on to going over question 7. So, ladies and gentlemen, now this is a tough one. We're going to be solving for D here. Now we've got VF squared equals VI squared plus 2AD. Now remember, reverse BEDMAS, and we have to focus on the chunks. So this is the chunk that has D in it. Keep this guy separate. Now we're going to move over VI squared. Now, because this is a plus sign, we need to be subtracting here. So we minus VI squared from both sides. That cancels. And we have our VF squared minus VI squared is going to equal 2AD. Now, because these guys are all touching each other in a clump right there, they are not following social distancing. Can't help it, guys. Come on, COVID's on. COVID jokes are happening. So, because these guys, when they don't social distance, it means we're multiplying. So, we now need to divide out the 2 and the D there. Oh, A, excuse me, as we're solving for D. Beg pardon. So, divide out 2A from both sides. So, D is going to equal VF squared minus VI squared over 2A. Cool beans? Cool beans. So now we're going to go on to number 8, and we are going to solve for T. So we've got our, now remember, ladies and gentlemen, T's on the bottom. What do we do when we got our unknown as our denominator? Mathematically break it to the top. So remember those methods that we went over earlier? Well, I am going to choose the shortcut method, and I'm going to swap those places there. So for number 8, once I trade those, I am going to wind up with T squared is equal to 4 pi squared MR over FC. We are so using that equation later. Yeah. So now, ladies and gentlemen, we square root both sides to get rid of that square. So T is going to equal 4 pi squared MR over FC square root. All right. Next question, number 9. We're going to be solving for VI. Now, this one's going to be a bit tricky, guys. So remember, we have to get rid of everything else away from that piece, that chunk. Well, because they're adding here and these guys are all being multiplied, we have to keep this chunk together, okay? So they're going to stay together, and we can move that whole chunk over to get away from the VI. So with number 9, we have our VF squared is equal to VI squared plus 2AD. I am going to subtract 2AD from both sides. The 2AD must stay together. You can't break them apart. You can't multiply just 2, or you can't take away just 2. You have to take the whole thing together. Okay? So we are then going to have VF squared minus 2AD, which is going to give us VI squared. What do? Square root. Root both sides, ladies and gentlemen. That will cancel out the squared. And so VI is going to equal VF squared minus 2AD. Square root the lot. Cool beans? Cool beans. And the last one we're going to go over is number 10. And number 10, we are going to be solving for VF. Now, this one, ladies and gentlemen, is really tricky, okay? So, with this guy, D is, I guess I can start writing on this guy. So the first thing I need to do if I want to solve for VF, now notice these are in brackets, ladies and gentlemen. That's in brackets. Because it's in brackets, that's the last thing I'm going to deal with. Anything that is not social distancing and has no sign in between them, that is multiplying. So, because we're going to multiply the COVID virus if you don't social distance. Terrible jokes. So, ladies and gentlemen, you're going to take this T, divide the T divide the half. Now, I don't like dividing by half, so I'm going to multiply by 2. Mathematically, it's the same thing. So I'm going to multiply by 2, and I'm going to divide by t, and it's 2 over t on both sides. So 2d divided by t is going to equal oopsie, I wrote it in the wrong order. Bonk. There we go. vi plus vf. Now I'm solving for vf, so I got to get rid of that vi. Well, they're adding, so I'm going to subtract vi from both sides. That cancels. So 2d over t. Now this is a whole term, so we got to keep that whole term together. Minus vi is going to equal vf. Rightio? All right. So if you guys have had any issues with this particular topic, ladies and gentlemen, make sure you come see me.
Grade 10 report cards are printed. We're ready for our report card crew back at the office.
Okay, I gotta go and stuff some report cards. Being 2 o'clock, I'm probably not gonna finish this video today. So we are gonna come back tomorrow to finish this, and which means it'll be a quick costume change, okay? Okay, so ladies and gentlemen, see you all. Next topic. Well, actually, this actually isn't a bad time to stop the topic because when you scroll down, oh, come on, computer, you're being a butt. There we go. There we go. So this is a great time to stop and go to page 9 of your workbooks, those big, thick, coil-bound things I gave you in class, and do number 1 and some of the practice problems there. Okay, so do number 1. You are already done these, and now I really want you to practice these. I want you guys to really take the time with those, and because this is super important. We're going to be doing this all of physics. Then tomorrow we'll come back with the same video and we'll look at sig digs and scientific notation. So pause the video and come back to this later. I'll go stuff report cards. Catch you guys on the flip side. See you all later. Ladies and gentlemen, I'm back from stuffing report cards into envelopes. We're going to keep going with our physics. So we left off with question 6. Cool beans. We're going to go on to going over question 7. So, ladies and gentlemen, now this is a tough one. We're going to be solving for D here. Now we've got VF squared equals VI squared plus 2AD. Now remember, reverse BEDMAS, and we have to focus on the chunks. So this is the chunk that has D in it. Keep this guy separate. Now we're going to move over VI squared. Now, because this is a plus sign, we need to be subtracting here. So we minus VI squared from both sides. That cancels. And we have our VF squared minus VI squared is going to equal 2AD. Now, because these guys are all touching each other in a clump right there, they are not following social distancing. Can't help it, guys. Come on, COVID's on. COVID jokes are happening. So, because these guys, when they don't social distance, it means we're multiplying. So, we now need to divide out the 2 and the D there. Oh, A, excuse me, as we're solving for D. Beg pardon. So, divide out 2A from both sides. So, D is going to equal VF squared minus VI squared over 2A. Cool beans? Cool beans. So now we're going to go on to number 8, and we are going to solve for T. So we've got now remember, ladies and gentlemen, T's on the bottom. What do we do when we got our unknown as our denominator? Mathematically break it to the top. So remember those methods that we went over earlier? Well, I am going to choose the shortcut method, and I'm going to swap those places there. So for number 8, once I trade those, I am going to wind up with T squared is equal to 4 pi squared MR over FC. We are so using that equation later. Yeah. So now, ladies and gentlemen, we square root both sides to get rid of that square. So T is going to equal 4 pi squared MR over FC square root. All right. Next question, number 9. We're going to be solving for VI. Now, this one's going to be a bit tricky, guys. So remember, we have to get rid of everything else away from that piece, that chunk. Well, because they're adding here and these guys are all being multiplied, we have to keep this chunk together, okay? So they're going to stay together, and we can move that whole chunk over to get away from the VI. So with number 9, we have our VF squared is equal to VI squared plus 2AD. I am going to subtract 2AD from both sides. The 2AD must stay together. You can't break them apart. You can't multiply just 2, or you can't take away just 2. You have to take the whole thing together. Okay? So we are then going to have VF squared minus 2AD, which is going to give us VI squared. What do? Square root. Root both sides, ladies and gentlemen. That will cancel out the squared. And so VI is going to equal VF squared minus 2AD. Square root the lot. Cool beans? Cool beans. And the last one we're going to go over is number 10. And number 10, we are going to be solving for VF. Now, this one, ladies and gentlemen, is really tricky, okay? So, with this guy, D is, I guess I can start writing on this guy. So the first thing I need to do if I want to solve for VF, now notice these are in brackets, ladies and gentlemen. That's in brackets. Because it's in brackets, that's the last thing I'm going to deal with. Anything that is not social distancing and has no sign in between them, that is multiplying. So, because we're going to multiply the COVID virus if you don't social distance. Terrible jokes. So, ladies and gentlemen, you're going to take this T, divide the T, divide the half. Now, I don't like dividing by halves. I'm going to multiply by 2. Mathematically, it's the same thing. So, I'm going to multiply by 2, and I'm going to divide by T. And 2 over T on both sides. So 2D divided by T is going to equal oopsie, I wrote it in the wrong order. Bonk. There we go. VI plus VF. Now I'm solving for VF, so I got to get rid of that VI. Well, they're adding, so I'm going to subtract VI from both sides. That cancels. So 2D over T. Now this is a whole term, so we got to keep that whole term together. Minus VI is going to equal VF. Rightio? All right. So if you guys have had any issues with this particular topic, ladies and gentlemen, make sure you come see me.
Grade 10 report cards are printed. We're ready for our report card crew back at the office.
Okay, I gotta go and stuff some report cards. Being 2:00, I'm probably not gonna finish this video today. So we are gonna come back tomorrow to finish this, and which means it'll be a quick costume change, okay? Okay, so ladies and gentlemen, see you all. Next topic. Well, actually, this actually isn't a bad time to stop the topic because when you scroll down, oh, come on, computer, you're being a butt. There we go. There we go. So this is a great time to stop and go to page 9 of your workbooks, those big, thick, coil-bound things I gave you in class, and do number 1 and some of the practice problems there. Okay, so do number 1. You are already done these, and now I really want you to practice these. I want you guys to really take the time with those, and because this is super important. We're going to be doing this all of physics. Then tomorrow we'll come back with the same video and we'll look at sig digs and scientific notation. So pause the video and come back to this later. I'll go stuff report cards. Catch you guys on the flip side. See you all later. Good morning, Physics 20. We're back. Fastest costume change in history. So new day, new part of the classroom. So what we're going to be looking at today is we are going to be looking at significant digits in this part of the video. Now, significant digits are essentially how you round your answer. Now, this is something you probably have already done in Science 10, possibly, and for sure in math. Now, the thing about sig digs is I know everybody thinks they're boring and they're stupid and why do I have to do this? But the reason why we got to do this is actually really important, because if you don't, your math can be way off. And things like in engineering, there's this bridge in Edmonton where the engineer made an error with his significant digits. And thank goodness they caught the mistake in time, because if they didn't, the first car that would have driven over it would have collapsed the bridge. So it cost the government millions of dollars to go back and fix this, because this engineer made an error with his sig digs. His sig digs. So, ladies and gentlemen, this is important. And if you are planning on taking physics in the future and chemistry in the future, this is going to be something super important. Also to keep in mind, chemistry and physics use slightly different significant digit rules. I am teaching you the physics sig dig rules. If you ever have me for chemistry class, I will teach you the chemistry sig dig rules. There's a few differences. Sounds good, guys? Cool beans. So I know it's boring, I know it sucks, but we got to do it. It's important, it's vital, it's utterly imperative. And for your guys' purposes, I take off half a point every single time a final answer does not have appropriate sig digs. Every final answer for the rest of the time that I am going to be teaching you guys physics, 20 and 30. Okay? All right, so sig digs, important for you, cost you half a point every time you don't put your answers to sig digs. Sounds good? Okay, let the groaning begin on that front. Just round your answers, you'll be fine. So, ladies and gentlemen, this is one of those things that it is going to be a bit of a pain in the butt at first. Once you get the hang of it, you'll be doing this no problem. All right. Now, significant digits, these are the digits that we know for certain. This is a level of accuracy. And then plus an estimated digit that's going to account for errors. Okay. So, and this is, once again, it's important. So that way we're actually giving right answers, because physics is used for engineers to build stuff, for geophysicists to find oil, and for astrophysicists to get stuff into space. And you screw up on your sig digs and you're toast. Your project is done. All right? Okay. So, ladies and gentlemen, I'm going to put a star here, and I'm going to write memorize. You got to memorize these rules. I'm sorry. There's no way around it. So, all digits 1 to 9 count as significant digits. All right? So, if it's 1 to 9, significant. Leading zeros are not significant. So, for example, if you have 0.00274, these numbers are not significant. Okay? So, how many significant digits? I said 3, didn't I? Yeah, I said 3 and wrote 2 because Monday, even though it's Thursday. So, what we've got here, how many sig digs? 3. 1, 2, 3 sig digs. Okay? Sometimes you'll hear significant digits also called significant figures or sig figs. Potato, potato. Okay. Now, trailing zeros, these guys are to the right of the decimal, do count as significant. All right. So if we have 0.76212 zeros, okay, well, this guy is not significant because it's leading. These two are trailing. These are significant. So what that means, how many sig figs or how many sig digs? There are 5 sig digs in this number. All right. Okay. All right, let's scroll down a bit. There we go. All right. So, ladies and gentlemen, when you are finished doing your calculations, you're going to round your number to the appropriate number of significant digits. You are only going to round the answer when the entire problem is finished. The entire question must be done before you round to sig digs. Why? Errors again. Anytime you round, there's going to wind up being a tiny bit of error in there. And if you round every single step, those errors are going to add and become bigger and bigger and bigger, and you wind up digging yourself into a massive hole, shoving yourself into a hole. So don't do that. Round at the very last step and use all numbers in your calculator from every step to step. Use all numbers, only round last step. That's how the diploma exam people do it. That's how we do it. Okay? Okay. We will talk more about that a little bit later. All right. Correction pretty much every day till the end of the course. Alrighty. So, ladies and gentlemen, last step, very last step. So, the addition and subtraction rules for sig digs we don't use very much because we don't use a ton of only multiplication or addition and subtraction in physics. We do a lot of multiplying and dividing. So therefore, these ones we don't use a lot. Okay. However, your very last step, when you take all of the numbers added and subtracted together, you go and look at all the numbers that you had in your original question. The number that is going to have the least amount of decimal places, okay, so the least precise answer determines the number of decimal places in your answer. So addition and subtraction rules are all about are all about decimal places, all about decimals. That is what you're going to round to, okay? So ladies and gentlemen, only decimal places, okay? Okay. So let's look at an example. So let's take some numbers here. We've got 274.0271. I'm going to add this number to 10.2271. Okay. So, ladies and gentlemen, oops, I wrote a whole bunch of stuff down that I did not want to write down. Let me fix this. I was just copying from above ips instead of writing down the number I wanted to. So when you add these two numbers together and you go through and do your addition, okay, so 1, 7, 2, 2, 4, 8, 2, okay, what is going to happen? Now we've got all these decimals, but who's got the fewest number of decimal points? Well, this guy. How many decimal points does he have? 2. So that means we have to round our answer to 2 decimal points. Okay? All right. So I'm going to take my final answer and I'm going to take 284.2. Okay, we're pausing here. We're going to, before we get our last digit here, I'm going to remind you guys how to round. It's really important that you guys remember the rounding rules. I know it may seem silly for me to be mentioning it now, but it's a question I get asked a lot, and I want you guys to make sure that you are comfortable with it. So I need to round to 2 decimal places. That means I have to have 2 digits after this decimal. It has to be rounded correctly. If it's not rounded correctly, you lose half a point, or your bridge collapses when you're an engineer. So we look at this decimal here. I want 1, 2 decimal points. Go to the third. You are going to look at your third and fourth decimal points. Does it need to round up? This is a 7. Now remember the rounding rules. If it is going to be 5 or above, you round up. If it is 4 or below, you round down. So this is a 7, so that means that this number is going to round up. Okay? So this is going to be 2.3. Okay, 0.23. All right. Okay. So you guys have to do this. It is super important in physics. I know it's a picky little detail. However, that's the nature of physics, guys. Okay? Details, they matter. Or your bridge collapses. All right. So, multiplication and division rules. These are the ones that we are going to be using every single day from now until you finish taking physics. If you go into a physics-based career, that'll be forever. Okay, so ladies and gentlemen, what you're going to do, you're going to count the number of significant digits in all the numbers that are being multiplied or divided. the number that has the least amount of significant digits, so the least total number of significant digits, determines the number of sig digs in your answer. So with this one, we look at all numbers in our initial values, all sig digs. Okay. So the example we're going to be using. So I'm going to go 22.50 times my 0.0970. That's a 9. It's a very wonky looking 9. And you multiply those together and you get 2.1825. Okay. Well, let's go and count our sig digs. 1, 2, 3, 4. Trailing zeros are significant. So this guy's got 4 sig digs. Leading zeros are not significant. 1, 2, 3. This guy has 3 sig digs. So therefore, ladies and gentlemen, you must round your answer to 3 sig digs. So I take my number, 2.1. Now I'm going to go look at my remaining numbers. I want 3 sig digs, so 1, 2, 3. I'm now going to go look at this 4th number here. Okay, well that 5 would round that 2 up to a 3. Would a 3 round up or round down? Round down. So that means this 8 is going to stay the same. Okay, so your final answer is going to be 2.18. Okay? Okay. So I'm sorry, ladies and gentlemen, but there is absolutely no help for it. You have to memorize those rules. That's just the way it is. You got to do it. All right. So ladies and gentlemen, exact numbers we're going to deal with sometimes, not a ton though. For example, if you have 800 people, those are exact numbers. I mean, you can't have 800.5 people. I mean, you can't have like half a person walking around, we don't chop people down the middle. So because they are a counted and defined exact number, so these are not considered when determining significant digits, even if you used it in the calculations. All right? Okay. Other cases as well, ladies and gentlemen, that we're going to be looking at later is we're going to be using terms like stop, or stopped, or at rest. Now, those values mathematically mean 0. However, I didn't say 0.00. I just said stopped. Those values don't have sig digs. It means you're going to be using 0 in your calculations, but you don't take them into account with your significant digits. Sounds good, guys? Awesome possum. All right. So another thing we're not going to be using a ton of is going to be recording sig digs on a ruler. Okay, I think we maybe use it like once, perhaps, something like that. So for this one, if we're going to be going with our centimeters, so we've got 1, 2, 3, 4, 5, etc., centimeters. So, well, let's look at this guy. We can only get one for sure value, and then an estimated value to account for error. Okay, so I can guarantee 3. Okay, so I look at 3, guaranteed, and now I go, well, we don't quite reach 4. Well, I can say that we are about 3.8 centimeters. Okay, can I say 3.84957? No, I just made those other numbers up. So this is why sig digs are important. It can tell us how precise of a tool we're using. The more precise your tool, the better. The more precise your tool, the more sig digs you can have. So the better the tech you're using, the better your math and your physics can be. Science and technology, they saunter along hand in hand, ladies and gentlemen. All right. So let's look at our ruler again, except this time, this is a more precise ruler. So 1, 2, 3, 4, 5, 6, 7. Okay. Well, now we've got these marks in between. Okay. So I can say, all right, 5 for sure. Now each of these is, so we've got 1, 2, 3, 4, 5. So each point is going to be 0.2 of a centimeter. So I'm going to scroll down, and that's going to be, so 2, 4, that's going to be 5.6. But I don't just say 5.6, it's just hanging a tiny bit over top of that edge. So I'm going to estimate it to be pretty close on. So like I want to say maybe 5.60. I'd even take like 5.61 centimeters. All right. Hey Chester, how's it going? Want to come say hi to the? Want to come say hi in my video?
Okay.
Yeah, come wave. I'm making a video. All right. There you go. Chester's here.
Oh, hi.
Hey, Chester's awesome. Right, guys? Cool.
Okay.
Physics lesson
Okay.
for next year.
Oh, fine.
I'm being prepared, guys. This is June.
Yeah, we just organized for you guys the special classes.
Exactly, right, guys? Here, we can even go full screen and we can show. There we go. See, classroom's empty.
Yeah, we have exams desks.
Yeah. You guys are going to be so happy. Exam desks? Yeah.
Have a great summer.
All right. Bye, Chester. Okay. And now where's the minimize screen button? Okay, there we go. Minimize screen button. All right, so that, ladies and gentlemen, is how we use sig digs when using a ruler. We're not going to use that topic a ton. We're just going to use that one, I think maybe once. Okay, but in chem, you'll use that in chem for sure. All right, so ladies and gentlemen, if you have any questions, make sure you come see me. This next piece we're going to look at is review from math in previous years, so putting numbers into scientific notation. Now, for scientific notation, this is vital. We're going to be doing this pretty much every single day until you're done taking physics. Okay, so a lot. Now, once again, review from previous years, super important. This is really handy when you're going to be taking numbers that have a zillion significant digits in your answer, but you're only allowed to have, say, 3 sig digs. You then are forced to put your answer into scientific notation. Okay, so for really big and really small numbers, it's super convenient to use, say, 5.4 times 10 to the power of 20, instead of rattling off 19 digits after 20 digits after that decimal place. So makes a huge difference. It also helps maintain the perfect number of sig digs. All right. Okay. So our example that we have here in the notes, well, we need to round this guy to 3 sig digs, but look at this. We've got a ton of sig digs. So we got to put this into scientific notation. So because I'll do another example as well when we're putting small numbers into scientific notation. So here our decimal place is there, and we're going to move this number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you move that decimal place over until it is in between the first 2 digits. So then I can have 5.2, I need 3 sig digs. So 5.2, you look at that 3, you take that 6 is going to round that 3 up to a 4. Now times 10, so each times 10 represents that place value, right? And we moved it 9 decimal places, so that's times 10 to the power of 9. And the units are kilometers, so put your units. I deduct half a point. If you don't put your units, write your units. Okay, I'm a mean teacher, right, Chester? All the things I take points off for? You give me the thumbs up.
You're doing good.
Thanks, Chester. Yeah, I never have an audience for my YouTube videos, so Chester's the man. He's like he'll be the first one to see me filming stuff, because normally I'm just sitting at home in my office filming.
Okay.
All right, thanks, Chester. All right, we will see you later. Okay, so that's your example of how to take a large number and put it into scientific notation. So now we have our next example. Let's do a really small one. So 0.00000007893. Okay, well that number needs to be rounded to, let's say 2 sig digs. Well, the problem here with this one, look at all these zeros. Well, these leading zeros aren't significant, but we've got numbers trailing, and this number is annoying to write. It's so many zeros, it's easy to lose track of them. So I am going to put it into scientific notation. I'm going to move this decimal to behind that first sig number there, right there. So we go 1, 2, 3, 4, 5, 6. Okay, so then we have 7 point. Now I need 2 sig digs for this example, so that means we need to look at a rounding. Well, that 9 is going to round that 8 up. And 8 up 1 point is going to be 9. So that would be 7.9 times 10 to the power of. Now, on the example we looked at initially, that was a large number, and we had to move our decimal place to the left, so that's positive. Here, this is a small number, and we had to move our decimal places to the right. And that means we have to make this negative. So we move them 1, 2, 3, 4, 5, 6. So that would be negative 6. Cool beans? Cool beans. So ladies and gentlemen, this stuff is vital. It's utterly imperative. You got to know this. It's vital. You need it. So do some practice problems on page 3 of your workbooks, which I will have given you in September. And ladies and gentlemen, pause the video, go do some of these. You need to know how to do this. If you need any help or have any questions, make sure you come see me and I can help you through it. Sounds good? Okay, pause the video and then come back. We're back! Excellent. I'm assuming you've paused the video and done those practice problems. And now we are going to go on to our next piece. I know, this is a super long video, guys. Okay. We are going to look at how to convert units. Now, this particular unit conversion table is on your data sheet. The data sheet that I gave you guys at the beginning of the year in September. Okay? You got to know how to do this. You 100% got to know how to do this. All right? Okay. Once again, I'm going to give you questions in grams where your calculation is only going to be able to be done in kilograms. I am going to be giving you guys questions in centimeters where you have to use meters. And in Physics 30, I'm going to be giving you guys questions in nanometers when you have to be doing stuff in meters. Unit conversion is just what we do. Okay, and the units that we use are generally the SI units, so your standard units that are going to be used for all these calculations across the world. Okay, so you got to know how to convert units. You just got to know how to do it. Now, why would I be so cruel as just to give you numbers in grams and where it really needs kilograms? Well, the thing is that sometimes the tools you have available will measure in one set of units, but you need to do your calculations in another. Okay. All right. So this data sheet is going to be this data table is in your notes. On your data sheet. Use it. Know how to use it. And these are just your conversion factors here. There's another one that you are going to be using on your review assignment, lesson title hint. It's called Pico, and it's a little p, and it's so tiny. It is a 10 to the power of negative 12. Okay, so let's look at how to use this. Now, these guys are going to be compared to any unit. Okay, so we can think of it as there would be a 1 in front of it, and then this would be the standard. So let's say I'm going to be working with grams. Okay, so this would be grams, or the gram would be after the fancy unit. So you can imagine a little gram after each of these: a kilogram, a hectogram, a decagram, okay? Whatever, centigram, milligram, microgram, whatever. Then on this side, you would have a regular gram, okay? So you would have 1 gigagram is equal to 10 to the power of 9 grams, okay? 1 gigagram is equal to 10 to the power of 9 grams. 1 megagram is equal to 10 to the power of 6 grams. Same when we come up here. 1 milligram is equal to 10 to the power of negative 3 grams. Okay? Okay. So, and the best way to use this is with unit analysis. I know some unit conversions, you can either multiply or divide by 1,000, multiply or divide by 100. Now, in an exam or in real life, you're not going to have me there to say, oh, do I multiply or divide by 1,000? Okay. Sure, you can use an app on your phone, but really it's a pain in the butt when I'm using my kitchen scale. If I have to think, oh, do I multiply or divide by 1,000? Okay. Can you use analysis? I have done unit analysis in my kitchen once or twice. Exactly. It's a thing. Maybe I'm just weird, but you know that already. Okay. So using that table, we are going to do unit analysis to convert units. This is honestly the most effective way to convert units, and it's going to be a tool that you use in university. I had chem profs in university who'd get mad at you if you used equations. You had to use unit analysis, especially with stoichiometry. He would get so mad. You wouldn't even give us points if we used n equals m over m. We had to do unit analysis for a stoic. So it's a tool that you probably will use if you guys decide to go on to science. So we'll be doing some stuff with unit analysis on and off throughout the year and into Physics 30. Okay. So we're going to be converting 5,500 millimeters into kilometers. So ladies and gentlemen, how we do unit analysis is you are going to write out the value that you have. It is sometimes easier if there's no units on the bottom half to put it over 1. So then that way it's easier to visualize. And then we are going to multiply this by a fraction. Okay, put your dividing line there. And now we're going to be using this conversion table up here to determine what we need to multiply or divide by. Well, let's first see, we need to get rid of these millimeters. So let's cancel out millimeters. Well, you don't have to know how many millimeters are in a kilometer. Let's convert it to meters first. We know that based on our table, now in this case, it's no longer grams, it is meters. So you just get rid of those other units. 1 millimeter is equal to 10 to the power of negative 3 meters. Well, I want my units in meters. I want to cancel out those millimeters. If I want to cancel out something when I'm rearranging an equation, what do? Multiply, divide. Divide. Okay? You do the opposite equation. Well, here, this is on the top. I want to get rid of the millimeters. So I put this millimeters on the bottom. So my 1 millimeter, okay, is equal to 10 to the power of negative 3 meters. Okay? So I now look here, I've got millimeters on the top, millimeters on the bottom. They are going to cancel. That means my units are now in meters because that's the only unit I've got left. Now what I'm going to do, I'm going to multiply by another phase. Okay? Because I don't really want meters. What I really want is kilometers. So I go over here. I'm going to erase all these dudes. And I'm going to find kilo. Well, kilo is my prefix for kilometers. So I put my meters there. And then I go and I get rid of this. And I put my meters here. Well, in 1 kilometer, there's 10 to the power of 3 meters. I want to get rid of that 10 to the power of 3 meters. Okay? So I go 10 to the power of 3 meters here because, look, I want to cancel out those meters. I don't want meters. I want kilometers. And so I put my 1 kilometer there. I go and I look at, okay, well, I've got meters. My meters cancel, and now I'm left with kilometers. Now what we do to solve this is you are going to multiply everything that's on the top together. So 5,500 times 10 to the power of negative 3. Enter. Then you're going to divide by the product of everything on the bottom. 1 times 10 to the 3. So 1,000. So you're going to divide, and 1 times 1,000 is 1,000. So you take this guy, so 5.50 times 10 to the power of negative 3, enter, divide by 1,000, enter. Then that's going to give you your answer. So, ladies and gentlemen, when you get this in your calculator, you get 0.005500 kilometers. Well, that's not. So what we do is we are going to put this into sig digs, okay, scientific notation. So when we look at this, I've got 4 sig digs, so I need to have 4 sig digs. So 5.500 times 10 to the power of 1, 2, 3, negative 3, and you write your units, kilometers. You have to write your units with your final answer, ladies and gentlemen, because if you just write 500, well, heck, how do I know what that is? 500 elephants? I don't know. I would know what it should be for the question, but how do I know that you know? And that's the whole point of marking stuff, is to see if you know what you're doing. There's no magical dipstick I can go up to your brain and say, yeah, you know how to do units. No, I can't do that. You got to put the right units. And you want to know why units are also important? There was this Mars project that NASA was doing, and they wanted to send this big, expensive, fancy thing out to Mars. And guess what they did? They had a subcontractor who was building a thing, and then they were building their thing, and they were using metric units because NASA uses metric. Well, guess what? Their subcontractor was using imperial units. They didn't talk to each other, so when they put it together, the thing didn't work, and it blew up as it was going into space because everybody used the wrong units. Had they written down their units and actually talked to each other about it, then they wouldn't have had this problem. Another time, there was this plane, and I can't remember what air company it was, but there was this one airplane that was flying across Canada, and it had to make an emergency landing in, I think it was Manitoba, because the guys used the wrong units to fill up the gas, or the airplane fuel. I don't know what they use for airplanes, but the fuel they used, it was supposed to be in one set of units when you fill it up. It was like liter or gallons or something, and they use liters. And the plane literally ran out of gas midair and had to glide into an emergency landing in Manitoba. So that's why units are important. That's why you write down your units at your final answer, because if you don't, your Mars spaceship will blow up or your airplane will have to glide to an emergency landing. Not fun. All right, guys. So we're going to scroll down here and we're going to do a couple more because it's what we do. We repeat things and repeat things and repeat things. And why do we repeat things? Because brains learn that way. The more and more you do something, the more and better you get at it. So the more of these you do, the better you're going to be at them. I know. Same way with sports. That's why when you're going to be playing hockey, you are going to practice your stick handling again and again and again and again in all sorts of different scenarios. So that way you just do it without thinking about it. Same with physics, guys. Same with physics. Same with anything. Okay. So convert 20 kilometers an hour to meters per second. Now this one, we're doing a lot of, an absolute lot of, a ton of this. I will be getting you guys convert kilometers an hour to meters per second and meters per second to kilometers an hour all the time. Okay. So same idea. We've got 20 kilometers / hour. Now, sometimes I write an R after my hours. I'll just write an H to be consistent with the question. So ladies and gentlemen, when you have a dividing line here, that slash, that's a dividing line. You're going to take that H and you're going to put it on the bottom. Okay? We're then going to now convert our units. Now, this is a tricky one because we're having to watch out for both meters and hours here. It's time and distance. So let's do one at a time. Get it? One at a time. Yeah. So I'm going to convert meters first. Okay. Now, when you go back up to your table, ladies and gentlemen, you are going to see that in 1 kilometer, there are 10 to the power of 3 meters. So what I'm going to do is I'm going to take my 10 to the power of 3 meters and put that there. Now, the reason, hey, Mr. George, do you want to come say hi to the kids in my video?
Sure.
Yeah, come say hi. Chester's, come say hi. This is like, this video, everyone's saying hi in this one. There you go. Yeah, we're filming. We're organized. Woo! All right, so, ladies and gentlemen, where is my... There you go. Now we're back to having me in the corner of the screen there. Okay, so then we got where are we? Meters. We got meters up on the top here, kilometers on the bottom. These kilometers are going to cancel. When you have one on the top and one on the bottom, they cancel. Now we're left with meters per hour. Because hours are still on the bottom. We don't want meters per hour. That's an annoying unit that doesn't get used much. So, but what we do want, unless you're going to be like measuring the speed of a snail, but we are going to look at meters per second. So we now need to convert hours into seconds. Now on your data sheet, you will have a value that is going to show you 3,600 seconds is going to equal 1 hour. Okay? All right. So we want seconds. Where do we want seconds, on the top or on the bottom? on the bottom. Seconds go down here. Okay, where do we want hours? On the top, because we want to cancel out those hours. So we cancel hours on the bottom, and now we have meters on the top and seconds on the bottom, which is what we want. So now we are going to multiply everything on the top. So 20 times 1,000, enter on your calculator. Divided by 3,600, enter. Okay? All right. So when you get this, you are going to wind up with 0.2283. Let's actually write this properly. I'm reading the wrong spot on my notes, and I was writing the answer to the next question. You're going to wind up with 5.5 repeating meters over seconds. So let's write this in sig digs. We need 2 sig digs here, so you're going to have to round your answer to 2 sig digs. So when we have 5.5555 dot, 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 well, we're going to look at these numbers here. Well, these numbers are going to result in this guy rounding up to a 6. And when this guy rounds up, you're going to have this guy going to a 6. So you are going to have 5.6 meters per second. As my square around my answer didn't go nice. There we go. Much better. Kind of. Good enough. Sounds good? Sounds good. All right. So, ladies and gentlemen, another thing that we would be looking at, this is the type of conversion that we would be looking at in our, I think it's our, depends on when I want to do circular motion. If I want to do circular motion either before or after energy, so either our third or fourth unit. Depends on when I want to do circular motion. But this is one we do in circular motion. Objects in orbit. Okay, we convert years to seconds and seconds to years. So we've got 720,000 seconds into years. So what we're going to do, we're going to take our number here in seconds. I'm going to put it over 1 to make my life easier. And now let's convert this into hours. Okay, and then we can go hours to days and then days to years. Okay, so we want to get rid of the seconds. So there's 3,600 seconds in an hour. So that means I'm going to put my seconds down there in 1 hour. I am then going to cancel out my seconds. Okay, so now I'm left with hours. So now I am going to need to convert my hours into days. Okay, well, how many hours are in a day? 24. So there are 24 hours in 1 day. So that's going to cancel. Now I am left with days. Well, we want to get this into years. So how many days are in a year? 365 days in 1 year. Days are going to cancel. Well, guess what? The only units I'm left with now are years. So notice here though, most things are on the bottom. So this would be this guy, times 1 times 1 times 1, which is 720,000. Enter, bracket, 3,600 times 24 times 365, bracket, enter. So you need the product of these guys together, 720,000 divided by the product of these three. Okay? When you put that together, you're going to get 0.022831 years. Now, ladies and gentlemen, did I put that into right sig digs or not? Let's check. 1, 2, 3, 4, 5, 6. Trailing zeros are significant. Okay? So this is not significant. 1, 2, 3, 4, 5, 6. I did. If I didn't, I would have cost myself half a point. I know, right? So, ladies and gentlemen, pause the video here. Go and do these questions. Okay? And then come come back to the video. You got it? Awesome possum. We're back! I'm assuming that you have now paused the video and that you have gone and done those practice questions in your workbooks and are ready to go. And if you have any questions, you're going to come see me, right? Awesome. And then I will answer your questions. So we're going to scroll down. All right. This, ladies and gentlemen, is our last topic here for the video. I know this is a super long video. Okay. It's going to be like 2 days to film it. Okay. So, ladies and gentlemen, with this guy, we're looking at graphing techniques. Now, this is super important. We're doing a ton of graphing in physics, and I am all in Physics 30. We are going to be also taking what it is we are looking at, our graphs data, and we're going to be putting them into y equals mx plus b, and we are going to be solving things that way. Now, so graphs, important. Now, why are graphs important in physics? Because it's a visual way to represent data. You can see the patterns of how an object is moving by looking at a graph that you can't always necessarily easily see just by looking at a set of numbers. And you can also do things like calculate the slope.
Chester, when you have a chance, can you please see Sandy? Chester, see Sammy?
Sorry, announcements. You can do things like calculate the slope, and the slope is going to have certain meaning in the graph. You can do things like calculate the area, and that area is going to mean something in the graph. And you can even take your graph data, put it into y equals mx plus b, and solve algebraically or on your graphic calculator for stuff. Like, it's really important. You can get a ton of data off of them. Y equals mx plus b, that's next year, that's Physics 30. Now what we're going to be doing is just simply looking at some of the basics of graphs. Okay, so this should all hopefully be a review of Math 10. All right. Okay. And there's some Science 10 in here too. So, ladies and gentlemen, your manipulating variable, or manipulated variable, whatever you want to call it, sometimes called independent variable, this is the one that you are controlling. This is the one that you are measuring hard data. Now, the tip with this one for when it comes to your questions is your manipulated variable is going to have evenly spaced data. So, for example, 10, 20, 30, 40, 50. You've controlled that data. You've made sure that every piece is 10, 20, 30, 40, 50. Okay? Okay. So that always goes on the x-axis. Now, remembering back from graphing, and that's your x, that's your y. Okay? Your responding variable, that goes on the y. Now, what is the responding variable? It's the results of your experiment. It is the results of the data you're gathering, what you're measuring. You don't have control over that data. That's going to be the results of your experiment. So what you're going to do is you're going to select a scale. Okay. Now, ladies and gentlemen, the scale needs to be appropriate. I do not want to see a massive sheet of paper with a squidgy little graph in the bottom. That's silly. Okay, you can't do math off of that. When I give you a piece of graph paper, I want the whole thing taken up. I want that whole darn page filled with graphing stuff. So none of this nonsense in a graph. Big graphs, big graphs. Okay, when it comes to graphing, bigger is better. Okay, so ladies and gentlemen, your x and y axis should be an appropriate size. They don't have to be the same scale. Okay, and once again, it should take up 2/3 or more of the page, both x and y. I want a big graph. Now you're going to select a scale that's easy to read. So intervals of 1, 2, 5, 10, etc. So we're going to look at how to do this in a moment with a practice problem, and we're going to go over this. Okay. So your step number 3 is going to be plot the points. Fair enough. You learned how to plot points previously in math. Plot the data on your graph. Now number 4 is you're going to draw the line of best fit. Now, this is going to be harder for me to demonstrate because I've got a writing tablet over here. I might be able to write it on the touch screen. I'll have to try that, see if I can do that. Okay. So what we've got is, this is important. Do not connect the dots. Okay. Connecting the dots is a child's drawing thing. We don't do that in graphing. Okay. We do not force the line to pass through 0, 0. Not all data is going to go through 0, 0. Not all data is supposed to go through 0, 0. The line of best fit is the general pattern of your data, okay? It tries to represent a general trend of all plotted points, okay? So sometimes stray points may be like way off if your data is kind of going up like this and you've got one way up there. Well, you can put a question mark beside that. And that could be a source of error. If you have a point that's way off your pattern, that can be discounted for error. Interpolation, reading a value in between data points. Extrapolation, extending the line and reading beyond available data. And that's something we're going to do next year in Physics 30. So we're not really going to do that so much in Physics 20. Okay. Step 5, you are going to graph title your graph. You must title your graph. You lose points if you don't title your graph. Okay? So be descriptive. Don't say graph. That's not a title. That's not a good title. Don't say physics. Well, there's a lot of stuff in physics. So what I want to see is y variable versus x variable. So if it's a distance time graph, you can write distance versus time, d versus t, good enough. Okay, that is the type of graph I want, title I want. So it's not like I'm asking you to write 3 paragraphs. That'll be your university lab report graphs. Yeah, I've had graph titles that were like, let's look up a full paragraph. Yeah, pretty crazy. All right, and then you're going to determine your slope. Now, slope is important. It's going to tell you all sorts of things. Now I can't find my data sheet. I think it's in my bag. Yeah, I accidentally shoved my computer on top. It's not even my computer, my husband's computer, on top of my data sheet. So just flatten that out a bit. It's crinkly, but it'll do. So, ladies and gentlemen, you don't need to memorize your slope equation. You have it. You recognize the data sheet I give you start of the course in September? You have, under this section here, your trigonometry and geometry. See where it says line? You have m equals delta y over delta x. M and y equals mx plus b is your slope, okay? And delta means change in. So your slope equation, ladies and gentlemen, is going to equal your y2 minus your y1 divided by x2 minus x1, okay? Okay. So, ladies and gentlemen, that we're going to be using that a lot. All right. The slope is going to be very valuable. All right. So, ladies and gentlemen, a couple of key things when you're calculating your slope and using your equation. You use points only along the line of best fit and not actual data points. Yes, I can tell the difference, and you will lose points if you do this. Okay. Why is that important? Why would I take off points for that? Because it would reduce accuracy. How do we know that the data points aren't complete outliers? How do we know just by looking at a table which values are going to be off? You don't. Okay, so get data points off of your line of best fit, not off your table, or I will deduct points. Okay? Okay. You are going to include units. No units, I take off points. You're going to use 2 points that are far away from each other on the graph, so that way you get the best representation of the data. It's going to be more accurate. Show your work. We're going to talk a lot about how I want you to show your work in future. And the physics equation, it should be able to fit into y equals mx plus b. That is something that we're not going to spend time with in Physics 20. We don't really need it for Physics 20. In Physics 30, we're going to do a ton of stuff with this. Oh yeah, ton of stuff. All right. So Physics 30, y equals mx plus b. Physics 20, not so much. Okay. So practice problem. We have data, and we are then going to go through our graph and look at all of these questions here. Now, I'm just going to pause filming for just a moment, and then I'm going to get myself some digital graph paper, which we are then going to jump over. Okay? All right. Back. So I got graph paper, ladies and gentlemen. Now, what I need you guys to do is I need you guys to have your notes out for this one. Okay, so what you're going to do is you're going to go to the notes booklet, which you've already been writing your notes in, and you are going to find this page here. Okay, so you guys see this page? Okay, this one's got my answers on it. Now, that is what we're going to be working off when it comes to questions. All right. Now, I can't jump back and forth between browser tabs when I'm filming. So it won't film. It'll just keep filming this screen even if I do go to another tab. So that's what we're going to be sticking with. All right. Okay. So I've got graph paper here, ladies and gentlemen, and we're going to start with our question number 1. As it's talking about arrhythmia, a disease that causes people's heart to beat irregularly. And I'll take my glasses off. It hurts my eyes to wear glasses in front of the computer. That's why all my videos I have no glasses on, whereas in class I have glasses. Okay, so the first thing we're going to do is we're going to look at your data table. Okay, so you guys see your data table there? Okay, I want you guys to look at that data table. And we have time elapsed and we have number of heartbeats. Well, notice our time elapsed, so our step 1, okay, you can also go back a page in your notes to look at your steps for drawing an appropriate graph. Okay, so see your steps, have that available too. Okay, so when you look at your notes on the previous page, your step 1 is selecting the axis. Well, your axis, remember, is our manipulated variable on the x and your responding variable on the y. Well, when you look at your data table, how can we tell what is the manipulated and what's the responding? But what values are changing? Okay, and how they're changing? Well, both are changing. But we look at this our estimated time is 0 seconds, 10.0 seconds, 20.0, 30.0, 40.0. We've got control over that. So because we have control over that, that means that is where we're going to be on our x. That's our manipulative variable. Whereas when you look at the number of beats, that value is all over the place. There's no real pattern that you can see at this point. That means that's going to be on your y. That's your responding. So I am sorry, I don't have a ruler tool. I know. So this is good. Graphing is going to be really tough. I don't have the ability to make it super nice and neat. I want to try something here. I'm just going to pause filming and I'll be right back, because this is going to be interesting. All right, I'm back. I had to go grab a ruler. The computer is a touchscreen computer, so that means I should be able to write on it with my finger if I have a ruler, so I can fold the screen down and use a ruler when I need to. So that's what I'm going to be doing. I'm sure there's a better way to do it, but it's me and tech. They don't get along. The fact that I am now a YouTuber and making YouTube videos is in fact pretty sick. It's very advanced for me. All right. So, ladies and gentlemen, the first thing we're going to need to do is we're going to need to draw our axes. So I'm going to flip this screen down. You guys get to look at the ceiling while I use a ruler to draw my axes on this computer. Okay? All right. So I'm going to take my axis, take my ruler, and I'm going to draw a nice straight line there. Now this is as best as I can get here, guys, so I'm sorry if this is going to be a mess. I am fully expecting your guys' paper graphs to be a little bit nicer than this. There we go. Okay, it's as straight of a line as I am going to be able to get. Okay, so I have my axes. I'm going to erase those random dots because we don't need random dots on our graph. That's messy. All right, so now I'm going to label my axes with units. All right, always label your axes. So we have on the y-axis, that is going to be the number of heartbeats. Okay. Cool? Okay. And then, ladies and gentlemen, we are going to then have on your X your time. Okay? And that's in seconds. All right. Let's see if I can scroll down a little bit. I can't. It's annoying. Oh, but that's actually okay. Maybe. Well, I can kind of see the bottom of my... Yeah. I'm going to redraw that axis line. It's not on that bottom part of the graph, and that's where I want that. So bear with me while I draw this. Okay. So I want this line not there, there. That's where I want that line. Okay. This is a lot harder to do on the computer than it looks, guys. So thank you for your patience. I appreciate it. Okay. There we go. So there is our time in seconds. All right, so now step 2, when you go back to your notes and you look at your notes and you see step 2, you are going to see your creating of a scale. Now, this one takes some time to get used to doing. I know it's a pain. I know it's tricky. And there's going to be times where you're going to have to make your graph and erase your scale. Make your scale and erase your scale. Make your scale and erase your scale. No, it's a pain. But I want my scale to take up as much of my page as I can get it. Okay. I do not want a squidgy graph all crammed in there. I can't see it. I can't mark it. You can't get math off of it. It's not helpful. Big graph. Okay. Well, fortunately for us, let's look at our x-axis. That's easy. Well, that one, it goes up by 10. I'm not going to change that. However, I'm just going to go up by 10. That's going to make my life easy. However, the problem is I am not going to go 10, 20, 30, 40, 50, 60. If I did every single line as 10, then that means my graph is going to be like that wide, and that's not helpful. I don't want a teeny graph. I want a big graph. So I'm going to select data points across that whole x-axis. I'm going to select, say, I don't know, let's try 5. So if I do 5 points, I could do, say, 1, 2, 3, 4, 5, and then that'd be 10. Yeah, I think let's just do that. And then that way, each point is going to equal 2. So, all right, so we go 1, 2, 3, 4, and 5. So 1, 0, 2, 4, 6, 8, 10. Okay, now 10, 12, 14, 16, 18, 20. And then 22, 24, 26, 20, 22, 4, 6, 8. That's 30. 2, 4, 6, 8. Oops, 2, 4, 6, 8, and then 40. 2, 4, 6, 8, 50. That's 50. 2, 4, 6, 8, and 60. Okay, there we go. So notice that the time and effort that took, and I've been graphing since before you guys were born. I know, I'm old. So, ladies and gentlemen, it takes time to do this. Take your time. And I'm trying to rush this on the lesson so that way you're not sitting here for even longer staring at me trying to make a graph. So take your time with this. Really take your time, okay? Make sure you have a scale that works. You may have to do it 3 or 4 times, and that's okay. Don't feel bad. All right. Well, now we're going to look at our Y scale. Well, our Y scale is going to be a bit harder. We've got values that range from 0 to 62. And we've got 9, 21, 34, 45, 53, 62. That's a pain. But what I'm going to do is because I'm still going 0 to a ballpark of 60. I'm going to go with the same points as 10. Because that worked on my x-axis, it should work on my y. And I want my graph to take up a ton of space. So do I have to go by 5 again? Or can I go by more points? It depends. So when you look at your graph, yeah, you know what? We'll go by 5. My graph will then go from about up to here, and then that'll be okay. That'll take up a good chunk of that space. So I'm going to go by 10. I'm going to keep the scale the same. If you want to make it a bit different, you can. There's nothing holding you to keeping the scale the same. Your scale's going to be different. It's okay. All right. So I'm going to go my same thing as I did before. So we go 1, so 2, 4, 6, 8, 10. And then 2, 4, 6, 8, 20. 2, 4, 6, 8, 30, 2, 2, 4, 6, 8, and 40, 2, 4, 6, 8, 50. That's a 4. And then 2, 4, 6, 8, 60, 2, 4, 6, 8, 70. Now, why did I go up to 70, ladies and gentlemen? Because I've got a data point above 60 at 62, so I have to go up one more point on my scale. Okay. So I have my graph set up. I've got my paper looking nice. Now I'm going to plot my points. Okay. My time is my X and my number of heartbeats is on the Y. Well, in this case, my data is going to go through the origin. I'm going to make my data points blue. So here I do have a 0, 0. Okay. It's on my data point. 0 times 0 beats. Okay. So 10 is my X. And then I have 9. So I'm going to go to 10. Now that is 8. So I'm going to go right in the middle there. And that should be 9. And then at 20, it's 21. So I'm going to go up my 20 line here and across. Now that's 22, so it's going to be right in the middle there. And then at 30, it's 34. So I'm going to go up. This is a lot easier if you use a ruler. And it's 30, so 30, 32, 34. Okay. And then we have 40 and 45. So there's my 40 line. So I scroll up this guy. And then we're at 40, so 42 and 44. So 45 is going to be in the middle there. And then we've got at 50 seconds, we have 53. So I scroll up to my 50 line. 52, 53 is going to be in the middle. And then my last one is 62. So I go to my 60 line and then I scroll up and then I get to 60. And then 62 is the next one. Okay, so I have my data points, ladies and gentlemen. I have completed that next step on the graph. You're on your notes. I think that's what step number 3. Yeah, so 30 spot the points. We've done that. Well, the next thing we've been asked to do is draw your line of best fit and calculate the slope. Okay, so for drawing the line of best fit, don't connect the dots. You take your ruler and you're going to get one that's going to be the best representation that you can. Now, in Physics 20, most of the time, much of your data that I'm going to give you is going to be close to being a proper line of best fit. So it's going to be close, all right? So you guys got to look at the ceiling again while I draw my line of best fit as I flatten that out. Okay, so I can use my ruler. I'm going to switch colors for my line of best fit, and I'm going to go with pink, because I can. Now this one is going to go through the origin. I'm going to put my ruler down here and I'm going to try and get my ruler to go through all of the points. Okay, not to go through all of them, but just to kind of get close to where I want it to be. Now, this is not going to be perfect because I'm on the computer here. I am sorry, guys. I apologize. There we go. All right, I changed the color on me to light blue, but that is okay. If that's the worst thing that happened when doing that, I'm okay with this. So I'm actually surprised I didn't do and delete everything, because that's generally what happens to me when I do stuff like this. So notice my line of best fit. As we have beautiful line. It's as straight as I could get while drawing on a touch screen with a ruler held up against the screen while you guys were watching the ceiling. So that, ladies and gentlemen, notice it doesn't go through all the points. It doesn't go through this one. It's close. It goes through that one. Doesn't go through this one. Doesn't go through that one. Goes through this one and kind of through that one. So you can't use your data points to calculate your slope. Use not spots on your line of best fit. Okay. So our next step is we're going to calculate the slope. So I'm going to pick 2 points on my slope. I want on my line of best fit for my slope. Pick 2 points that are easy, ladies and gentlemen. Easy points. Pick points that are like on your line that are actually on your points that you already know the value of on your line. Well, let's see. I am going to pick. What is a nice, easy one? I am going to pick for my points. You know what? I can pick data points, ladies and gentlemen. There, I like this one. I like picking data points that are in the intersection between 2 lines. It makes it so much easier to get your data. That's what I'm looking for, is I'm looking for points that are far apart that intersect 2 of my grid lines. It makes my life infinitely easier. And there's one. Okay. Those 2 points, ladies and gentlemen, that I just put red X's on, those intersect grid lines. It makes life infinitely easier to calculate your slope. Okay. So remember that your slope is going to equal your change in the Y over your change in the X. Okay, that's an X. All right, so we're going to calculate the slope. That's 2 on your question. So I have picked the point of, it is 52 and 54. So that is the point that I picked there. So I'm going to use my graphing skills to get that. And then I got to 4. So that's 4 on the X. And on the Y, that's 2, 4. So I've picked 4, 4. Okay. So with your slope, you take your delta Y. So I'm going to take my Y values. So it's going to be 54. Okay, that's the Y, 2 minus 4. And then we divide that by delta X, so 52 minus 4. Okay? Okay, so we can solve for that. So that would give us 50 divided by 48. All right, I'm not feeling mental math today, so I'm going to grab my calculator. You'll find very rarely am I actually feeling mental math. Okay. And 54 minus 48, let's actually get to a spot where we can actually do work on the calculator. 54 divided by 48 is going to give you a value of slope, which is going to equal 1.125. Now, ladies and gentlemen, your slopes are going to be a little bit different. When I graphed this earlier, I got a different slope. I got a slope of 1.07 or 1.06 repeating. Well, when I look at these, the thing about doing graphs by hand is that you are going to wind up with some minor errors and in getting your exact line of best fit, getting your points plotted. So when it comes to this, I'm going to be reasonable. Because I got 1.07 one time and 1.125, that's fine. I will accept both of those as correct answers. I will, if you get 1.08, if you get 1.14, those I'm all going to accept as fine, so long as you've shown your work and I can see you've done your work reasonably, etc., and your graph is done properly. But if you get, say, 8, well, then there's something wrong. I would not accept 8 as a correct answer. All right, well, we need sig digs. Well, we're going to go back to our chart, ladies and gentlemen, and Generally with graphs, I tell you how many sig digs I want. In this graph, I would want 2 sig digs, okay? So therefore, I am going to write around this to 2 sig digs, and I would write the slope. All right, well, that would round to 1.1. Now, the thing is, we need units, ladies and gentlemen. And what does that slope represent? Well, what did I divide by? Y divided by x. What are the units for this, for the y? Beats divided by seconds. So it is beats divided by seconds. So your units, when you write your units at the end, it is going to be your heartbeats per second. What does the slope represent? Heart rate. Your slope, the slope of this graph represents your heart rate. Isn't that cool? I think so. All right. So, ladies and gentlemen, in your notes, it says, what's your linear equation of the graph? Don't worry about it. We're not going to worry about getting your linear equation of the graph. We'll worry about that next year in Physics 30. And then we got a question about extrapolation. Let's do that. Okay, so what would the average number of beats? Yeah, let's not do that one. I don't feel like we don't need to do that one today. We don't do a ton of extrapolation in Physics 20 anyway. We'll do that. That's next year. Okay, so ladies and gentlemen, those are the graphing skills that I need you to know how to do for Physics 20. So linear equations, extrapolation, that is all stuff for next year. We'll do that next year. The video is already long enough. I'm doing like 4 filming sessions of this. So ladies and gentlemen, what am I missing? What would I deduct half a point off of this? I want you to look at my graph and see what am I missing. Title. I am missing my title. So I would need to, at the top, heart beats versus time. There you go. There's your title. All right. Okay, ladies and gentlemen, that is the end of this section of notes. That's the end of the review section of physics. So these are essentially the skills that you are going to need in order to be successful in Physics 20. Okay, so if you have any questions with any of these, if you find any of this stuff tricky, make sure that you come and see me and we will go over it. We can talk about it. We can get you sorted. Alrighty-o? All right. So, ladies and gentlemen, I hope you guys have a good rest of your day and no fires, injuries, or explosions. Talk to you guys later. Bye.